Hello students, in this session we are going to discuss the RAFT consensus algorithm for permission blockchains. So in previous session we have studied Paxos consensus algorithm. There are some limitations of this Paxos algorithm. Uh, Paxos is the current standard for both teaching and implementing the consensus algorithm for permission blockchain. This Paxos algorithm is very difficult to understand and very hard to implement. But as compared to the Paxos, RFT is the new protocol proposed in 2014. It is much easier to understand, and several open source implementations of the RFT protocol is available. So key features of RFT are uh, it has strong leader. A leader does most of the work in RFT consensus algorithm, issues all log updates. So we will see what is this log updates. Then it has there is a one node which acts as the leader, uh, and leader is selected by using the election process. uh, for selecting the leader, it uses a randomized timers to elect the leaders. Then membership changes, new join consensus approach where the majority of two different configurations are required. So we will see the details of this RFT algorithm. So before understanding the RFT algorithm, we have to understand the replicated state machines. We have studied state machine replication in previous sessions. It allows a collection of servers to maintain identical copies of the same data. Identical copy of the duplicate copy of the same data is maintained over the several servers. And it continue operating when some servers down. Despite of the failure of some servers, the system can recover from the identical copies, or we can say from the other servers. A majority of the servers must remain up. So there are many applications of this replicated state machines, and typically these replicated state machines are built around a distributed log. So we have to understand what is this distributed log. So the distributed log, each server stores a log containing commands, and consensus algorithm ensures that all logs contain the same commands in the same order. State machines always execute commands in the log order. So they will consistent as long as command execution have deterministic results. So these servers will store a log containing the commands, and this consensus algorithm ensure that all log contains the same commands in the same order. So in this concept of distributed log, client sends a command to one of the server. Server adds the command to its log. Server will change its state after receiving the command. Server forwards the new log entry to all other servers. And once a consensus has been reached, once every server will agree to update its log, each server state machine will process the command and sends it reply to the client. So log copy of the each server is updated, and it will reply to the client after updating the log on all servers. So there are two types of failures, non-Byzantine failures and Byzantine failures. In non-Byzantine failures, fail nodes stop communicating with other nodes. This is clean failure. So this fail node will detach, will get detached from the systems. They will stop communicating and fail stop behavior. These nodes will not misbehave in the system. But in Byzantine fault, failed nodes will keep sending messages, false messages. In this uh, incorrect, these messages are incorrect messages and misleading messages. Failed node becomes a traitor in the system. So failed nodes may misbehave in the system, and it is difficult to detect such kind of failed nodes in the distributed system. So such type of faults are called Byzantine faults, and it is very hard to handle such kind of Byzantine faults. So there are several limitations of Paxos. Exceptionally difficult to understand. It is very difficult to understand this protocol. The dirty little secret of the NSDI community is that at most 5 people really or truly understand every part of the Paxos protocol. This is the observation by anonymous NSDI reviewer. This Paxos protocol is very difficult to implement. There are significant gaps between the description of the Paxos algorithm and its real world implementation. So the final system will be based on an unproven protocol. This is said by the Tsubby authors. So this protocol is difficult to understand. Paxos protocol is difficult to understand, also difficult to implement. So there must be some easy protocol alternative to this Paxos. And alternate to this Paxos protocol is RFT protocol. So this RFT protocol we have to understand in this session. RFT consensus algorithm. This algorithm is very easy and simple algorithm. In this algorithm, servers start by electing a leader. So leader is elected. Sole server habituated to accept the commands from the client. So the leader will accept the commands from the client, and after receiving the commands from the client, it will enter them into the log. The leader will enter the commands into its log and forward them to the other servers, and will tell the other servers when it is safe to apply these log entries to their state machines. So this leader will receive the commands from the client, will enter the commands into the log and forward the commands to all the other servers, and it will also tell to the other server that when it is safe to uh, apply these log changes into their state machines. So RFT algorithm decomposes the problem into three fairly independent sub problems. The RFT algorithm is divided into three parts, or you can say into three sub problems. First part of the RFT algorithm is leader election. So how servers will pick a single leader. So election will take place and the leader will be selected. Then how the second part of the RFT algorithm is log replication. How the leader will accept the log entries from the clients. The leader will accept the commands from the clients. Then it will update the log and it will propagate them to the other servers and ensures their logs remain in the consistent state. And third part of the RFT consensus algorithm is safety. RFT basics, uh, the servers. RFT cluster consists of several servers. Typically, it consists of 5 servers, and each server can be in one of the 3 states. Each server can be leader, each server can be follower, and each server can be a candidate. And the states of the server will change. It will start in follower state. When the server will start, it will start in the follower state. Then election will take place to elect the leader. Then when the follower will go into the will go for election, then it will become a candidate for the leader. And when the candidate will receive a certain number of votes then that candidate will become the leader in this RFT algorithm. So there are three types of servers: leader, follower, and candidate. And followers are passive. Followers simply reply to the request from their leaders. So there are some basic terms related to this RFT algorithm. The terms is the terms act as the logical clock, allow servers to detect and discard obsolete information. This logical clock allows the server to detect and discard obsolete information. Each server maintains a current term number. Each server maintains a current term number, includes it in all its communication. This current term number is included in all its communication, and server receiving a message with a high number updates its own number. When the server will receive a high term number, it will update its own number. A leader or candidate receiving a message with a high number becomes a follower. So leader or candidate receiving a message with a high number will become a follower in this RFT algorithm. So RFT basics: servers communicate through uh, RPC calls, idempotent RPCs. So there are some RPC messages. Through that messages, the servers will communicate to each other. The first type of messages is request vote. This is for selecting a leader. This is initiated by the candidate. The candidate who wants to become the leader, that candidate will request to the other nodes uh, for vote, for getting the vote. So it will issue the request vote message, and when certain number of messages are certain number of votes are received, then the state of the server will change from candidate to the leader. Then second type of RPC messages are append entry. This is for leader. These messages are this append entry message is initiated by the leader to replicate the log entries over the all servers and provide a form of heartbeat. So this leader provides a there is a mechanism that through that mechanism all the followers will come to know that the leader is alive, leader is in the workable condition. So for that purpose a mechanism of heartbeat is used. So it provides a form of heartbeats. So it sends some leader sends some empty append entry calls, and from that calls the followers will come to know that the server is active. If the server is not active, then the followers will go to elect the new leader by performing the election. So we will see how this will happen in the next slides. So leader elections. So whenever the servers will start being a follower and remain followers as long as they receive valid RPCs from a leader or candidate, and these servers will remain followers as long as they receive a heartbeat, or we can say append entry calls from a leader or candidate. And when a follower receives no communication, when follower will not receive any heartbeat, any append entry call, then uh, follower will come to know that there is no leader in the system, and the followers will go into the election state to elect the leaders. So how the leader is elected, we will see. When a follower receives no communication over a period of time, uh, uh, it starts an election to pick a new leader. So when the leader fails to send a heartbeat, followers notice at different times the lack of heartbeats. When the followers will notice the lack of heartbeats, then the followers decide to elect a new leader in the RFT algorithm. So when the follower will not receive a heartbeat, then follower will start an election. It increments its current term. and it will change its state from follower to the candidate state. The state transition will take place from the follower to the candidate state, and followers will vote for itself, and also this follower will issue a request vote RPC in parallel to all other servers in the cluster. And the follower will request to the nodes for getting the votes by using the request vote RPC, and it will change its state from follower to the candidate. It becomes a candidate for election. So this follower, when it will go into the election state, it will continue as a candidate. It will act as a candidate, and it will remain a candidate it will remain in the candidate state until it wins the election. Another server or when the another server becomes the new leader, it will come in back into the follower state. It will come back. The state transition will take place from candidate to the follower when another server becomes the new leader. A period of time goes by with no winner, and when there is no winner after certain time, then also the candidate and server will come into the followers state. So winning an election, for winning an election, the candidate must receive votes from a majority of the servers in the form in the cluster for the same term, and each server will vote for at most one candidate in a given term. The first one, it will vote for the candidate who contacted first one. So majority rule ensures that at most one candidate can win the election. At most one candidate will win the election, and winner becomes the leader and sends heartbeat messages to all of the other servers to assert its new role as the leader in this RFT consensus algorithm. So when the some node will win the election, that node will become a leader, and candidates may receive an append entries RPC from another server claiming to be the leader. If the candidate term is at greater, if the candidate's term is greater than or equal to the candidate's current term, the candidate recognizes that leader and returns. The candidate will come into the follower state when the candidate will receive a greater term number. Otherwise, the candidate ignores the RPC and remains in the candidate state. So split elections, no candidate obtains when after certain time, if no candidate obtains a majority of the votes in the server, in the servers in the cluster, and that means if the election is done and if the no candidate will win the election, then each candidate will time out and it will start a new election after incrementing its term number. So log replication, now after some node will become a leader by winning the election. What is the role of this leader? Leader does most of the task in RFT algorithm. A leader accepts the client's command. It appends them to their log. It will append the commands to their log, and it issues append entry RPC in parallel to all the followers. It will say to the followers that the followers has to also update their logs. So this apply the entry to their state machine once it has been safely replicated. So entry is then committed. So you can see how this will happen. Client sends a request to the leader. Leader will append the command to its log, and leader will propagate this command to all other servers. So leader stores the request on its log after receiving the request from the client, and it forwards it to its followers. Followers will receive the request. You can see there is a server which receives the not server, there is a leader node that will receive the request from the client. Client will that leader will receive the request from the client, and the leader will update its log, and it will forward this request to followers also. Followers will also update their log. Followers store the request on their logs and acknowledge its receipt, so that the leader will come to know that the follower also updated their log. So leader tallies the followers acknowledgements. So once it ascertains the request has been processed by the majority of the servers, when the leader will come to know that majority of the servers has updated the log, they have processed this log command has been whatever the append entry command that has been processed by the majority of the servers, then it updates its state machine. The state of the system will change. So leader every follower checks the heartbeat of the leader, and if they don't receive the heartbeat, then the followers will come to know that the leader has failed, and they have to elect the new leader. So you can see leader's heartbeat convey the news to its follower, and they update their state machines. So in this session, students, we have studied the RFT algorithm. In RFT algorithm, the first phase is to perform the election. Every server starts as a follower, and then followers will try to participate in the election, and when the followers will participate in the election, they will going to go into the candidate state, and candidate will send the request vote message to the followers, and followers other servers will vote for the candidate, and if candidate receives certain number of votes, then that candidate will win the election, and that candidate will become the leader. And then leader, what is the role of the leader? The leader will receive the commands from the clients. Leader will update its log, and it will send a append entry command to all the servers, all the followers, and all the followers will also update their log, and they will acknowledge the updation to the leader. And when leader will receive the acknowledgements, then state of the system is finalized. So this is how this RFT algorithm works. This RFT is much easier to understand and implement as compared to the FACSOS, and has no performance penalty. So students, in this session we will stop here. In this session we have studied the RFT algorithms. Thanks for watching session. Goodbye.